Hey guys. So for the chemical processes lab, you guys will be required to use a table that looks like this, which describes the specific gravity of ethanol in water as a function of both temperature and the weight percent ethanol. So of course on the left-hand side you have the weight percent ethanol, on the top you have the temperature, and in the middle you have the specific gravities. Reading this table may be a little bit confusing at first, but once you get the hang of it, it's not too bad. So what you have to remember is that for things like this, when it's just a three-digit entry, this does not mean that at 86% ethanol and 10 degrees C, the specific gravity is going to be 697, because that makes approximately 0 sense. So what happens is that if for each column, above it somewhere, you're going to have a leading entry here, where in this case it's just the one right above it. That says like point something something. In this case, it's going to be 0.83. What you have to remember is that for all the values on the table, these numbers are going to have a 0.83 in front of them also. So this leader carries its way down the entire column. That's to say, for this number, it's going to be 0.83697. This is going to be 0.83441, etc. down the column. For this column, you can't really see it because I've only taken a small portion of the table, but above it you're going to have a 0.83 also somewhere, and that means that these values will be 0.83 whatever. Over here, these two values here are going to have 0.82s in front of them because we have a 0.82 here. This, on the other hand, will still be a 0.83. So great. But what happens if we want to find a value that's not really listed on the table? So let's say we want to find the specific gravity of ethanol at some weird percent, like let's say 85.5% ethanol, and at 10 degrees C. Let's keep it simple for now. What we're going to be using is something we call linear interpolation. So if you guys have seen this before, you guys can go ahead and skip to the next video, which is going to be on bilinear interpolation. That basically means that for bilinear interpolation, we're going to have a percent ethanol that's not listed on the table, and also a temperature column that's not listed on the table too. For regular linear interpolation, one of these guys will be known already, like we'll be at 85 or 86 or 87, or at a temperature that's already specified, like 10, 15, 20, etc. down the table. So for now, let's keep it simple with regular linear interpolation, 85.5% ethanol, and 10 degrees C. So we can imagine for a second that we have a graph. And this is at fixed temperature at 10 degrees C. So we're only considering the data in this column. Let's treat the weight percent ethanol, let's call it some variable W, like the x value if you will, and then the specific gravity as the y value, which we're going to call, well, rho, because it's specific gravity. So at 85, let's say, I don't know, this is 85. You're going to have some specific gravity as specified here. In 86, another one. It's going to be a little bit lower. In 87, another one. And it's going to be a little bit lower than that. So what we can do is to estimate a value between two known values, we can use linear approximation, which says that although we do not know the exact shape of the graph between these 2 points, we can just assume for the time being that it's going to be linear. Is that true? Probably not. But the error that's going to arise from us just saying, that, let's just say it's linear, that's going to be really small in comparison to everything else. Actually, the error term of this will probably just be in the 5th decimal place over here. So it's going to be really, really, really small. So small that we can just say, it's okay. So how do we get the equation of this line? What we can do is use something we call on the point slope form. So you guys have probably seen before y equals mx plus b. For point slope form, it's another way of writing the same line, except we use two known points that are already on the line. Sorry, one point that's already on the line. And from that one point, we can determine the position of another point on the line. And so this is the point slope format right down here, which says that y minus y0 equals m times x minus x0. M is the same thing from y equals mx plus b. It's just the slope of the line. y0 and x0 and x comma y are both points on the line. So all we need to do is we can get a slope. We can get a known point that's already on this line by taking either one of these endpoints. The slope we can just calculate by stuff we probably learned in like 8th or 9th grade. The slope between these 2 points. And then use that to determine the y value of the x value that we want, which is in this case 85.5. If you haven't seen this equation before, take a good moment and review it and take it down in your notes somewhere. This is really, really useful actually, especially when it comes to calculus, which if you haven't taken it, you'll probably take it sooner or later. Right? Cool. So let's rewrite this equation for the variables that we have here on this graph. Right? So that means we'll have, in the y, we'll have a rho. That means rho minus rho 0 is going to be equal to m times w minus w0. So what we can do now is we plug in points really. Let's also get in an expression for m in terms of these numbers here. Since I don't have that much space on the chalkboard, let's give these guys names. So let's say 85 here is going to be equal to w1. 86 is going to be w2. Their corresponding specific gravity values. This guy is going to be equal to rho 1. And this guy, remember 0.83697, is going to be equal to rho 2. Right? And this one here, we'll just call this something more interesting. Let's say W smiley face, because smiley faces are cool. And the rho value that we want to find that sits in between here somewhere at 85.5, let's call that rho smiley face. Remember, this guy is the one that we want, rho smiley face. Cool. So we know we have a given point that we can input here. We can take either the point w1 rho 1 or w2 rho 2. For the sake of this, let's just choose 1 because 1 is easier to write. Since we want to get this value over here, we can input w smiley face for this guy. So if we rewrite this, rho smiley face minus rho 1 is going to be equal to the slope. Okay, so what's the slope? Slope is going to be the change in rho over the change in w. In this case, rho 2 minus rho 1 over w2 minus w1. The entire thing times inputting the same thing for the corresponding positions, w smiley face minus w1, because we chose that as our point for point slope form. Cool. So everything with a number at the bottom and w smiley face we already know. So we can solve for rho smiley face. So it means rho smiley is going to be equal to, just move this guy to the other side. So that would be equal to rho 2 minus rho 1 over w2 minus w1, the entire thing times w smiley face minus w1, also plus rho 1. And that's it. You can do the same thing if we can work backwards, right? What happens is that, let's say we have a given temperature and we already know the specific gravity of the ethanol. Now, what we want to do is figure out the weight percent, and it's easy. So all you do is, instead of plugging in from all of these guys and solving for him, you plug in for everything except this guy and solve for him. And from there, it's just a matter of rearranging an equation, which you guys should be able to figure out on your own because you guys are smart. Right? Cool. So next time we'll be talking about bilinear interpolation, which is what happens when you have we want to figure out a specific gravity that is at a weight percent that's not listed here and at a temperature that's not listed here. Right? But like I said, that's for next time. If you haven't seen this stuff before and it's a little bit confusing, rewatch this video a few times and I'm sure you'll get it. This is pretty simple stuff. All right? Cool. I'll see you guys next time.